Hi, I'm Eric Lofstrom, professional wood turning artist and instructor. I started turning wood about the year 2000, and I have experience with a variety of tools. One of the tools that has stood out for me is the Round-Shank Convex-Bevel skew. This is a skew that I've developed taking different parts from other styles of tools and putting them all together in one tool. I have experience with all of the different types of skews that are out there, and I love all of them. They're some of my favorite tools, but this Round-Shank skew has really stood out above the rest. The Round-Shank allows the tool to glide across the tool rest so I can feel what's happening at the edge. The Convex-Bevel, well, it provides support for the edge directly behind the cutting portion of the edge. And the size of the tool allows me to practice proper biomechanics so that I have better finesse and better tool control. The intent of this video is to provide a rich understanding of the skew so it becomes a tool that you reach for time and time again. In particular, we're going to feature one tool that has found a really sweet spot in my tool arsenal, the Lofstrom 3/8" Round-Shank Convex-Bevel skew. I'm going to use this tool to explain the whys and the hows of the skew. The skills in this video have been intentionally selected to move from more simplistic to more complex. And while they're not the only way to apply the skew to a piece of wood on the lathe, I've found that they work very well for my students in learning and developing their skill level. It's my hope that the skills you adopt will enhance your confidence and experience at the lathe. These are three tools from my tool collection. The Lofstrom 3/8" Round-Shank skew on the left, a more traditional rectangular shank with a radius edge in the middle, and a thicker shank skew with a radius edge all the way to the right. My 3/8" Round-Shank skew has a convex bevel, and the other two skews have a concave or hollow grind bevel, as you'd find off the grinder. Like most of us, you've probably experienced some challenges with the skew. It can be a pretty unforgiving tool until you understand some of the characteristics that make up the design of the skew that you're using. Also, you need to understand how your body incorporates into the equation to help you control the skew at the lathe. We're going to talk a little bit about the design of the skew and how that impacts how it behaves when you put the edge to the wood. We're going to use this model of a radius edge skew to take a look at the three variables that make up the characteristics of any skew. First variable, cross-section of the shank. Second variable, edge profile as seen from the side. Third variable, bevel configuration that makes up the shape of the bevel. Let's take a look. First variable, shank cross-section. I'm going to simplify this a little bit. There's a lot of different variations on each design within each variable, so we'll keep it simple. First shape, more traditional, a rectangular shank cross section. Second shape, it's a little bit of a variation on this, but it's pretty common. Chamfered edges, a radius bottom, and a flat top. Third configuration is an oval skew. This one I'm going to do flat top, flat bottom, and a nice even curve. Fourth configuration is a little bit of a variation on this, but it's pretty common as well as an oval skew. One where the belly of the curve goes right into this radius lower edge. And the fifth configuration is a round shank. This is the first variable, shank cross section. Second variable is edge profile, looking at the skew from the side. Most traditional is about a 70-degree angle. And the bevel, or the heel of the bevel, or the bevel edge, mirrors that angle. Second is a radiused edge. where the bevel heel or the bevel edge mirrors the edge as well. And third configuration, which is a little bit of a variation on this, is one that has a straight section and then radiused. Straight section and then radiused. This particular design comes in a couple different bevel configurations with the heel of the bevel. And I'm going to draw this as straight and then curved, where it mirrors the edge. This section is the straight section. The third variable happens to be the bevel composition. Bevel composition can be a straight bevel, so looking at the long point, a hollow grind, and I'm exaggerating here so that you can see. This would be more typical off of a grinding wheel. And a third configuration would be a convex bevel. I'll exaggerate this as well. And a fourth configuration would be a multifacet, which acts or behaves a little bit like a convex bevel. This would be a multifacet flat, hollow grind, or convex. It's multifaceted. I'm going to draw this and exaggerate a little bit as well. Let's do a hollow grind. You may not have that many facets, but I'm exaggerating to make a point. And this can be done intentional or unintentional. Taking a look at these three variables, you have 5 versions of a shank cross section, 3 basic versions of an edge profile, and 4 versions, remember this can be intentional or unintentional, but 4 versions of a bevel composition. Combined, if you do the math, well, let's see, 5 versions times 3 is 15, times 4, you've got 60 different variations of a skew, 60 completely different characters. The specific skew I'm going to be highlighting in this video, the Lofstrom 3/8 inch Round-Shank Convex-Bevel skew. I know it's a mouthful, but it specifies the character of the skew. In the name it gives you, well, the variables. Round-Shank, 3/8 inch diameter. It's a straight edge, and it happens to be a convex bevel. So this is the basic character makeup of that skew. Now you might be wondering, why would I choose that configuration of skew? Well, we'll talk about that in just a minute. This skew behaves a little bit different than any other skew on the market right now, any of the other combinations, and there's good reason why I've chosen to use it. You might be asking, can I make all 6 cuts with these other designs of skew? Absolutely you can, but I chose this specific configuration because it makes all 6 cuts beautifully. It's very forgiving as well. If you use another design of skew, absolutely you could make those 6 cuts, but you may have a little bit more sanding, you might have some bruising of fibers, or you might find that it's a little bit temperamental and difficult to control. Let's take a look at the skew anatomy. There are 3 basic parts to any skew: the edge with a long point and a short point, a bevel on each side with the heel of the bevel, and the tool shank. These basic parts make up any skew. When we look at a convex bevel or a hollow grind bevel with the same thickness of shank, the edge has a specific geometry, but the bevel influences how that edge behaves in the wood. If you look at the shank thickness of each of these tools, this one's the skinniest at just over 1/4 of an inch, and these two on the outer sides are 3/8 of an inch thick. The edge configuration is actually the same at both of these. It's centered in the shank of the tool at approximately 30 to 35 degrees. The edge geometry would be the same at the edge, but the way that it behaves when you're cutting wood changes the character of that skew drastically. The convex bevel has a functional angle or a functional geometry at the edge of about 30 to 35 degrees. There's no other portion of the bevel that is contacting the wood if I'm cutting a straight surface or a flat surface. It's right behind the edge. But if I look at the geometry of the edge of the hollow grind tool, you'll see that that flat surface would actually go through part of the shank. The functional angle, as I go deeper in, becomes blunter. As the support of the wood rides up the hollow grind, that angle shifts. If I have the edge deep into a cut, the heel of the bevel is going to glide and actually make this a blunter functional angle. That means that as I go into a cut, the tool shank will have to be shifted to keep this edge steering in the direction I want to cut. The geometric angle and functional angle being the same on a convex bevel tool, the convex bevel skew means that once I have the angle of the shank established to have support behind the edge, I can glide that tool in that same orientation all the way through the cut. It gives me great predictability from the start of the cut to a finish of a cut. Let's take a look at another diagram just to give us an idea of what kind of cuts this functional and geometric angle play into. So taking a look at some diagrams to highlight the differences between the convex bevel and the hollow grind bevel, we'll look at a convex surface. On the outside of a cylinder, a hollow grind bevel is going to glide against the bevel, draw the edge back until the edge engages with the wood, and the geometric and functional angle at this point are the same. In a bead or a convex surface, same thing here. Bevel contact, draw the edge back so that it introduces into the wood, and the bevel contact is directly behind the edge all the way through the cut. The geometric and the functional angle are the same. In a convex bevel skew, there is really no difference. Draw back until the edge engages with the wood and proceed with the cut. The geometric and functional angle are the same. In a bead, same thing. Draw back until the edge engages with the wood. The geometric and functional angle are the same throughout the cut. There is no difference in a convex surface between the convex bevel and the hollow grind bevel. Let's take a look at where they really stand apart. In a concave or a coving cut, the two bevel designs differ quite a bit. The hollow grind bevel runs into some problems with the geometric and functional angles being quite a bit different. Bevel contact, draw back till the edge engages in a shallow cove, and the bevel support is maintained out at the corner of the cove. The functional angle then comes into play as quite a bit different from the geometric angle, bridging the support for the cutting edge way back at the corner or the heel of the bevel. In a deeper cove, the problem is only amplified. Geometric angle, pivot point as you enter the cut, and now the functional angle is quite a bit steeper. This is almost as though you're plowing wood as you go through. The convex bevel excels at a shallow cove, but runs into some difficulty in the deeper cove as well. Again, draw back till the edge engages in the cut, proceed with the cut, and the pivot point stays directly behind the edge all the way through the cut. There is no bridging effect because the geometric angle and the functional angle are the same. When we go into a deeper cove, we run into the same problems as the hollow grind. Geometric angle, draw back until the edge engages, glide that bevel into the cut, but now the edge is not supported directly behind the cut because this cove is deeper than the actual convex surface of the bevel. This skew would not excel over the hollow grind. The two have difficulties in a deep cove. Let's take a look at a flat cut or a straight cut to see the difference between the two grinds. When looking at creating a straight cut or a surface that is flat, the two bevel designs differ quite a bit as well. In a cylinder, a planing cut, the hollow grind will run into a problem because the geometric and functional angles are different. Drawing that edge back till it engages with the wood. As you go through the cut, the pivot point maintains on the bevel and shows the difference between the geometric and the functional angle. In an end grain or paring cut across the end of a cylinder, same phenomenon happens. Bevel support behind the edge, draw that edge back till it engages in the wood, and the pivot point maintains out at the corner. The farther into the cut, the more you approach the functional angle, which is quite a bit steeper than the geometric angle. And in a V cut, the exact same thing happens. Enter the cut with the bevel supported right behind the edge, and the farther into the cut that you go, the more the geometric angle and the functional angle differ. You'll also find that the deeper into a V cut that you go with this blunt of a functional angle, you'll end up touching on the other side of the V. You can't get quite as crisp a V from this style of tool. With a convex bevel across the surface of a cylinder, the support stays directly behind the edge throughout the cut. The geometric and functional angles are the same. At the end of a cylinder in a paring cut, same phenomenon. Draw the edge back, edge support is directly behind the edge on that part of the bevel. The geometric and functional angles are the same. And in a V cut, the same thing. Support maintains directly behind the edge all the way through the cut. Now you'll notice the geometric angle of the edge of both the convex bevel and the hollow grind bevel that I'm showing are the same, but this particular bevel design allows that edge to go all the way into the V. In looking at all 6 cuts, the convex bevel has an advantage over the hollow grind bevel in producing a straight surface and also a slight cove. Anytime that there's a convex surface that you're creating, both skew designs, both bevel designs behave pretty much the same, with the geometric and functional angles being the same. In any straight cut or coving cut, the geometric angle and functional angle being the same on a convex bevel skew give it quite an advantage. In my experience, this means ultimate tool control, resulting in less skates and catches, and greater predictability when I choose to use the skew. It also means amazingly clean cut surfaces, which minimizes the need for sanding. The skew is designed as a spindle turning tool, and in all of the skills I introduced in this video, I use spindle grain orientation. Spindle grain orientation means that with a blank between centers and the axis of rotation in the middle of the blank, all of the grain runs parallel to this axis of rotation. For your safety and success, I recommend clean spindle grain orientation only. There are a couple things that I want to cover that are really important in wood turning. They involve your safety. First off, eye protection. You notice I don't have safety glasses on at the moment, but I have several safety glasses that I can choose from. These happen to be 2 of my favorites. If you want to protect yourself further, choose a face shield or full helmet assembly. I have a face shield right here on the wall behind me. This one is by Uvex. It's really nice face shield because it has a frame all the way around the lens. This is super important. Another safety component of being in the shop is hearing loss. We need to protect our ears. A lot of the equipment that we use involve motors or fans that create a lot of background noise that we can get used to. The danger is that we can get used to it. That creates a lot of hearing loss. My choice happens to be hearing buds or earplugs. These are two of the earplugs that I would use. They're expanding foam earplugs. They're rated at a noise reduction of 33 decibels. Another really important safety concern that you need to protect yourself against is the airborne dust. Any of the dust that you can't see, that's what does the damage. This happens to be a respirator you can purchase from a home improvement store. One of the other components of safety that's super important is pay attention to the blast zone. That's where the wood would eject from the lathe if it comes off the lathe. That's about 90 degrees, plus or minus 10 to 15 degrees on either side. When you're starting the lathe up and you're bringing it up to speed, I always stand out of the blast zone. You should too. Also, make sure that you read and understand all of the safety guidelines and the manuals for all of the tools that you're using. One other safety component that we don't think about very often is fatigue. When I start to get tired at the lathe, it's time for me to turn the machines off, clean up the studio, and then go in and take a break. Lots of bad things happen when you're tired or distracted. When you're practicing your turning with the skew, there are several lathe accessories that can help you with your success. The first of which is your wood selection. I'm choosing radiata pine. You can find this at your local hardware store. Other good woods that you could use are spruce or fir. Radiata pine, spruce, and fir all give you great feedback on how sharp your edge is and your edge presentation to the wood. The second accessory is a good drive center. I tend to like a cup drive center, which is also known as a dead center if it's used in the tailstock. The next accessory that can help you be more successful when you're practicing is a good quality live center. I happen to really like the center point with a cup configuration. It helps keep the wood from splitting. The last accessory for your lathe to help you with success happens to be your tool rest. If you're selecting a tool rest and you have a specific project in mind, make sure that your tool rest is slightly longer on both sides so that you have support all the way to the end of the blank. One of my favorite practice woods for practicing basic skills with the skew is radiata pine. You'll hear me probably go back and forth, radiata, radiata, potato. I've heard it both ways. You can buy Southern Cross pine or radiata pine, or any kind of pine works great at the hardware store. This happens to be a 2x2 from a home improvement store. I bought a stick, I think it was about 6 or 8 feet long for a few dollars. Makes a lot of great practice blanks. I choose a blank between 4 to 6 inches long. Too long and you start to get into whip or vibration. Too short and you don't have as much real estate to practice on. One of the techniques that I use for marking centers doesn't require any special tool or any special jig. Just a pencil, your fingers, a little know-how, and a small block of wood. I use my finger as a gauge along the side and I scribe 4 lines. I've flipped the blank end for end and I'll do the same on the other side. Next step might be to mark the actual center with a center punch. Again, this side I'm just estimating. And I'm ready to put it on the lathe. I'm going to place my drive center in the Morris taper, make sure it's seated nice and firm. Bring up my tailstock and mount it between centers. There are 6 cuts I use the skew for. The first cut, the planing cut. Peeling cut. The third cut, the paring cut. Paring cut, long point down, Steering that bevel. The fourth cut, a Vee cut. Fifth cut, a rolling or beading cut. Sixth cut, a coving cut. And there you have it, 6 cuts with a skew. The planing cut is the first cut I'd like to introduce in this video. It's a great roughing cut, but it's also a wonderful refining cut, taking the blank from a square down into a cylinder. When I'm performing the planing cut, I'm going from larger diameter to smaller diameter. So in this case, I'm going from the corners down to a cylinder. I'm also focusing on using the short point. So long point up, short point down. I'm dropping the tool handle down to get the bevel in contact with the corners as they go past the edge. And I'm raising the handle until the edge engages in the cut. You need to be very careful to keep the long point out of the cut. So keep the long point high and only use the short point. As you notice, then I go down the cylinder. I'm going from larger diameter to smaller diameter, so I'm then easing the edge into the wood. The planing cut, in essence, is just like this. And you'll notice the shaving that I'm getting off a nice sharp tool rolls up into a straw or a tube. If you're having difficulty with this cut, stop the lathe and try it by hand, just like I showed. Once you get to the end of the blank where the corners are still proud, turn the skew around and go the other direction. Once it's close to a cylinder, plane the entire surface, getting a nice true cylinder. Again, if you're having difficulty with this cut, this is a bevel riding cut. Make sure to turn the lathe off and see if you can produce a shaving with control with no power from the lathe. If you have a sharp tool and good edge presentation, you should be able to create tubes where the shaving rolls up in a spiral. If you find that you're getting too aggressive a cut, that means that the bevel is not gliding on the cut and you're raking the edge across. With a little bit of experience, you can use almost the entire edge in this cut, but make sure to keep that long point out of the wood. It's a really fun cut to practice. It gives a beautiful surface, great shavings. So this time take a look at my foot stance and my leg movement to create the control at the edge. It's all about transferring my weight and doing it with control. Transferring your weight from left to right or right to left in a nice controlled manner gives you lots of tool control. Being able to create a nice true cylinder with great tool control and a great surface is a foundational skill. The next cut I'd like to introduce for the skew is a peeling cut. I use this in roughing cylinders down. I also use this in sizing a cylinder or a spigot. This is especially useful if you're getting ready to place the blank in a chuck. In using the peeling cut, I use it as a roughing cut and a refining of form. You'll notice that it's quite a bit rougher than the planing cut. The planing cut is much more a refining cut. Most people think in the peeling cut that you just take the edge and you shove it into the wood. That's not actually the case. You abuse the edge and you take the razor sharp edge right off. You actually rub the bevel or glide the bevel behind the cut. Draw the handle back until the edge engages, and then it's much like peeling an apple. You want to get underneath the skin but maintain underneath the skin. As I do this cut from a larger diameter to a smaller diameter, I almost take a swan dive type action. I start with the bevel gliding on the surface and then introduce the edge as I draw back the handle. The shaving's produced, and as I take wood away, I need to maintain the bevel contact and the edge underneath to do that peel. So I need to swan dive forward, but also allow the edge to go towards the center axis of the cylinder. The swan dive, handle down low, legs bent or knees bent. I go up and over. I'm now going to show the paring cut. Some people call it a shoulder cut, but it's paring the end grain or the ends of the fibers. I'll show two different paring cuts. I'll show one near the tailstock or live center, and then I'm going to do a peeling cut, which you've already seen, to get a smaller diameter and show you how I would normally use the paring cut. Paring cut across the fibers of the end of the cylinder, long point down. Gives me a very, very clean cut. I'll make a smaller diameter and then I'll show you how I would use the paring cut in making a shoulder for a chuck or a mortise and tenon joint. Long point down. That's all there is to it. Let me do that again. That peeling cut that I had already shown. Peeling to make a nice cylinder, and paring cut, long point down, steering that bevel to get a nice clean cut. This is a great way to clean up the fibers, the ends of the straws in the blank. It gives a really polished cut. No need to sand there. Much like the peeling cut, I have a similar stance. My knees are going to be doing the action. The tool is going to do a swan dive, long point down, and I'm swan diving in, swan diving in, swan diving in. My legs give me a lot of control and they give me a lot of precision with the tool. That swan dive motion, long point down, long point down. Show you with the lathe on. You get a lot more control and a cleaner cut if you do that swan dive action rather than just shove the long point in straight on the radius. Swan dive, swan dive. Same motion as the peeling cut. The next cut I'd like to showcase is a Vee cut. I use it in two different capacities. First one is to mark out details on the spindle, so to score a line rather than using just a pencil line. And the second way that I use it is to create a detail. A Vee cut creates a really sharp and crisp shadow line. Let's take a look. The first style of Vee cut, shank perpendicular to the axis of rotation, long point down. I'm going to do the same swan dive, but I'm not going to dive in. I'm actually just going to pivot and slice and almost back out with the long point. I'm going to use this in scoring a detail. For example, let's say that I already marked out a detail with a pencil line, two details, and I want to make them permanent into the blank so that I don't accidentally erase the pencil line if I change the cylinder size. Long point down, slice, long point down, slice. I'll do a couple more lines on here, marking out some sort of feature in my spindle, long point down, but you notice my handle is way down. I'm going to slice that long point into the wood and slice. This gives a really crisp detail, really crisp shadow line. But the fibers do tend to mushroom out or flare out on either side. So the next style of Vee cut that I'm going to showcase is a style that I do to create that crisp shadow line or that crisp effect. I'm going to do the same slicing action, same kind of knee movement or leg movement and swan dive, but this time I'm going to angle the tool ever so slightly, tilting it, and I'm going to start with the tilted and I'm going to end with my edge vertical. So from the left side, I'm going to tilt the tool so the edge is steering left, long point pointing right, and end with it vertical. Same thing, I'll repeat it on each of the features. If I go from the right side, it's the same thing in reverse. Tilt the tool to the right slightly, and vertical, and vertical, and vertical, and vertical. It's a very finishing cut. You don't want to take too big of a bite. So if I want to make this a deeper V, I need to now do a couple times on the right, and you'll notice the shaving builds up, and I need to do it on the left to relieve that shaving. Again, once or twice on one side, and once or twice on the other. Again, this is all in my knees and my legs. Take a look at my legs. It's the same motion as that peeling cut and the paring cut. You might notice that my knees are getting a little bit more dramatic. That's as I go deeper into the V. My legs have to bend a little bit more, or actually extend a little bit more the further I get into the V. If it's a very small detail, I don't have to have as much of a dynamic movement. The larger the detail is to be able to cut from start to finish, the larger my body movement or my leg movement needs to be. You may find that you want to refine way down deep in that little V, in the transition where the two facets meet. You can easily do that with your leg movement and have lots of control. Take a look at the crispness. Really crisp detail from the cylinder transitioning into that V, and then the crispness way down in the valley of the V and all the way on the other side. There's no reason to sand this type of detail if you have a sharp tool and good tool control. Remember, I'm using the long point down. I'm using the same swan dive type action all the way down into the very bottom, and I'm ending with my edge vertical. If I end with the edge engaged at the very bottom of the V, any little motion in the handle will make the edge engage and jump out of the V. You may have noticed that the Vee cut is a really nice transition from the paring cut. The Vee cut, we add one more variable. So instead of just paring and steering one bevel all the way down the face of the end grain, we now angle, going one side and ending vertical with the edge, and then repeating from the other side. This is a great exercise in your ability to create a symmetrical feature, going on the right side and then going on the left side and repeating the mechanics for both sides. The next cut I'd like to share with you is a rolling or beading cut. This is a great cut to practice with a skew. It's a little bit more advanced. It takes a more complex movement. Not only are your legs going to be doing the movement, but your hips are going to be moving as well. You're going to be rolling the tool as you also swing the handle, as you also do the swan dive action. So now it's going to be 3 different biomechanical principles operating all at the same time. In practicing your beading or rolling cut, you're going to need to establish the boundaries on the left and the right. We'll turn between these boundaries, but to establish the boundaries, let's do a Vee cut. I've marked out my lines for my boundaries, and I'll cut a succession of beads. I'm going to use long point down, Vee cut, to score those features. It's a great warm-up for that knee movement or leg extensions. Now I'm going to use the short point down. When I do the short point down, I'm going to notice that the fibers come up a little bit different than when I did a long point down cut. You'll notice they're a more open straw. Again, I'll do the right-hand side on my next feature, ending vertical with the edge. Gives me lots of control. When I end vertical, it tracks in that V groove and gives me lots of control. When you're practicing, practice all right-hand side and then practice all left-hand side. It'll give you repetition of motion. Now you may notice I'm trapping that short point into the V cut or into that V groove, and it tracks because it's going vertically. I can leave it at this, very simple open or shallow beads, or I could go very deep beads. If I go with a more pronounced bead or a deeper bead, I need to deepen the Vee cut to slice the fibers of the wood so the shaving ejects from the edge. If I want to keep it nice and shallow, that simple scoring of the fibers is all I need. You can see it's very, very, very clean detail. I'll make these first two a little bit more dramatic. So I'll take a deeper Vee cut, rescore the fibers. Notice I'm using long point down. And I'm coming in, since I practiced that Vee cut, I'm coming right into the same line that I originally scored. Short point down, rolling cut, ending vertical with the edge and perpendicular with the shank of the tool. This is a cut I'm going to sneak up on. Bevel and edge. Other side. Ending vertical. Right? Bevel, edge, that short point. It's a great one to practice picking up the cut. And notice I did a trapped ring on this one. For this cut, my body movement is feet apart, knees bent, tool handle down low so that the bevel is gliding on the wood for the entry of the cut. Roll the tool and lift my knees simultaneously and end in a vertical edge. I'd like to introduce the way I use the skew to cut a cove. I call this a coving cut. Depending on your edge configuration, the angle, and the profile of your skew, you may be more successful attempting the coving cut with a broad cove. If you want more success with coves and you want to do a deeper, narrower cove, your best choice is a spindle gouge. For this cut, I'll demonstrate a narrower cove between two features. And then I'll demonstrate a nice broad flowing cove between two more features. I need to establish the depth of the cove, or at least score the fibers lightly so that they don't chip up the other side of the cove. As I do this cove, that's a nice narrow cove. I'm going to make it broader, so twice that distance. But once I hit those sheared fibers, I need to switch and go the other side. Whoop! You may have a learning experience like that too. This is probably the most difficult cut with a skew. If I take a look at what happened, as I was initiating the edge, I came off the bevel because I moved the handle towards the tailstock too soon. As you initiate the cut, that's probably the most difficult part of this cut. That's what makes this an advanced skill. Let me go for that again. Anchored on tool rest, bevel contacting, short point. Wow, and you can see I just ragged that up, didn't I? There we go. Okay, much broader cove. I'm going to score at a couple different spots so the shavings have a chance to chip off. But I'm going to go a little bit deeper with this. There we go. Notice my foot and leg position, legs bent or knees bent. I initiate the cut, extend my legs, and then move my body laterally to the side. Go to the other side. The key points in your body motion and your leg movement is to make sure that you manipulate your body so that the bevel maintains contact throughout the cut. If the bevel loses contact in the cut, you're going to have a skate. It'll wipe out the details on either side of the cove. These are beautiful surfaces, cleanly cut. The most difficult part of this cut is initiating the edge contact. So, bevel gliding on the feature that you're starting the cove from, and then rocking through the bottom of the surface. A little bit easier version of this cut is a broader, shallower cove. That would be the one I would suggest starting with if this is a new cut to you. So now I've shown you 6 cuts that I use the Lofstrom 3/8 inch round shank skew to accomplish. The first cut was the planing cut. That's what I used to rough out all of my cylinders with this skew, taking off the corners, going from large diameter to small diameter, and then smoothing out the surface. The second cut was a peeling cut. I used this in sizing tenons or resizing the cylinder. It was very much a roughing cut. You can see some of the texture that was left behind. The third cut that I demonstrated was a paring cut. It's an end grain cut, slicing across the ends of the fibers to get a really clean surface. I use this in creating a nice crisp shoulder for any of my tenons or changes in diameter between cylinder sizes. The fourth cut that I demonstrated was a Vee cut, 2 different styles, scoring to mark a detail, and then also creating a nice crisp shadow line for a detail. The fifth cut I demonstrated was a rolling or bead cut. In this example, I didn't show very symmetrical beads, but I gave you the idea of right and left side, going a little bit more dramatic or a deeper V between the beads or a shallower V. And the final cut that most people don't use the skew to accomplish because it's pretty tricky is a coving cut, creating a concave surface that's cleanly cut. This is a bevel riding cut, and I demonstrated a teachable moment on what happens when the bevel comes off of the wood or out of contact with the wood. BioMechanics. What does that mean? Bio, living thing, mechanics, movement. It's movement in a living body. For me, biomechanics plays a huge part in my tool control. You've noticed in this skew video that my tool control is pretty good. When I have proper biomechanics, it allows me to do all of the cuts with success. But when my biomechanics get a little bit sloppy, my tool control suffers. Let me give you a couple pointers on how you can improve your biomechanics at the lathe. Let's take a look at my feet. When I'm standing at the lathe, if I have a wide stance with my toes slightly pointed out, I have more balance. I have a wider base. But if I were to stand with my feet together like this, I have a very narrow base and I have a very narrow movement or narrow pass with the tool that I can make with success. If I'm going to rough a blank into a cylinder or do a long planing cut, I want to have a wide base of support. My toes slightly pointed out at about a 45-degree angle relative to each other. And my knees then can bend to transfer my weight from left to right. If I'm going to do an exercise to practice this and strengthen my legs, I want to be able to lift up one foot and totally rely on my left leg to balance my body and my body weight, and then smoothly transfer my weight to my right leg or my right foot and lift up my left leg. This is a great basic exercise or a way to warm up your legs and get ready to do a planing cut with great success. If I have my feet in a narrow stance, I have a very narrow base with which I can balance. If I go right to left, left to right, my weight transfer is in a very small amount of motion, so I can't expect to be able to do a long planing cut with control. Let's take a look at my knees. When I have that wide stance and my toes slightly out, I can bend my knees and lower my center of gravity. Then I have a lot more control because my muscles are ready to transfer my weight from left to right and right to left. When you're taking a look at my upper body, my knees are bent. I'm not nearly as tall as I normally am when I'm standing up straight. When I'm standing up straight, I'm 6'2". But when I'm crouched down, I've lowered my center of gravity and allowed my base to be wide so that I can move from left to right and right to left with control. Great exercises to see if you can transfer your weight from left to right and right to left, keeping level shoulders, maybe sighting something along the wall that's nice and level. And now with the tool in my hand, I'm going to step up to the lathe, nice compact stance, and I'm going to do the same thing. My knees are bent, I have a wide base, toes pointed out, and now the tool becomes an extension of my core, and my hands are free to do the finessing of introducing the edge and the bevel to the wood. In doing the planing cut, you need to be able to transfer your weight from left to right or right to left. Notice my shoulders and my upper body as I do a planing cut. Making a nice true cylinder. If I don't have a smooth transfer of weight, my tool is going to go up and down into the wood, creating a really undulated surface. Not a smooth cut at all. Let's take a look at the biomechanics in a peeling cut. That was the second cut I introduced with the skew. For a peeling cut, I always take a wide stance so I have a great base. And I'm going to be bending my knees, locking the handle into my hips, and I'm just going to be raising my knees, both simultaneous at the same time. You'll notice my elbows are locked into my core, so I have nice stability. My knees are just bending and extending. As I bend and extend, my shoulders come forward so my head comes up and over the blank slightly. This is what I was talking about with a swan dive. My shoulders and my head come up over the blank. I'm sure you've noticed by now, I adopt a very compact stance. My hands choke up on the tool. My right hand is touching the tool shank as well as the handle, and my left hand is just used for guiding and placing the edge. Many turners will grip on the butt end of the handle. I don't like this approach as much because my wrist, elbow, and shoulder now become extra joints that I have to control. Even if I have really strong hands and really strong arms, my core is so used to balancing my entire body weight, making very small motions and very small movements, those muscles are used to very fine control. If I add my wrist, my elbow, and my shoulder in, those muscles are not used to balancing my weight and making very small motions. As they become fatigued, my arm becomes very loose and shaky. So, a compact stance, choke up on the grip, bring the butt end of the handle into your hip, and now it becomes an extension of your core. And this arm can relax and just steer the bevel. Now your legs and your core become the manipulator of how the tool handle acts. Again, my right hand can completely relax and take a really light grip, just guiding the bevel and the edge to contact the wood. What this translates into is if you do have a catch or a skate, there's very little force into that equation, and the tool will kick back ever so lightly and disengage the edge. It's not a big deal. It becomes a learning experience rather than what I call a PFE, pant filling experience. I'd like to introduce the biomechanics for a paring cut. Now a paring cut, I'll switch my blank out here. A paring cut, remember, is across the end grain fibers. This is one of my favorite cuts to do. It cuts across the end grain and cleans it up so nicely, but it can be a little bit of a crazy cut if you don't have good tool control. If you're fatigued and you adopt this end of the handle grip and your edge wavers, you can go from introducing just the long point to the entire edge in a matter of a moment. That's a really big catch. This is the exact same biomechanics as that peeling cut, that arcing or swan dive kind of motion. So my legs and my core and my body are doing the exact same motion, except my edge is vertical. I'm leading with the long point down, and I'm gliding the bevel that is in contact with the wood. That's what I'm steering. So my hips come over just slightly to angle the tool so that that bevel is steered, and then I do my swan dive. This is a really nice cut to be able to have that control. Again, the same motion as the peeling cut. The greater diameter difference between where you're starting the cut and where you're finishing the cut will determine how dramatic that movement is. The smaller the difference, the less movement in your knees. The larger the difference, the greater the movement in the knees. For the Vee cut, it's nearly the same motion as the peeling cut and the paring cut. Like the paring cut, I'm going to steer the bevel of the skew. So I'm going to bring my hips to steer that bevel in the direction I want the point to go. Here's perpendicular for the scoring cut that I started the Vee cut with. All I need to do is shift my hips or my weight towards my left to cut the left side of the V. And the last variable I need to change is I need to twist the skew ever so slightly. I'm exaggerating that rotation a little bit. This would make a wider V than what I've done on this blank. For this blank, vertical edge right here, handle over, edge placement like this. Now all I do to cut the other side of the V, twist the other way, and shift my hips the other direction. As I finish the cut, I'm going to extend my legs and move my hips over so that the edge tracks vertically in the groove. You'll notice also that the shank is perpendicular to the axis of rotation. Remember, that gives me a lot of safety and stability in that edge tracking. Let's take a look at the rolling cut. You'll notice that these cuts are gaining in their complexity. Changing out the blank for the rolling cut is a little bit more complex. Not only do you need to shift your hips as you swing the handle around to track vertically at the end of the cut, you also need to roll or twist your handle. That's where this hand is going to come in with controlling that edge. Remember, the rolling cut is the short point down. Everything else builds on the biomechanics. Wide stance, feet at 45, knees bent to initiate the cut, angle the handle against your hip, choked up in a compact stance, and extending your legs to come up and finish the cut. That's the rolling cut or beading cut. It's quite a bit more complex biomechanically than the other cuts. Just remember when you're practicing, use a cup drive or some way that it will allow the blank to slip if you get a skate or a catch. Also, remember, every skate, every catch, every little oops is a learning experience. Stop for a moment, take time to understand what's happening at the lathe between the edge and the wood. Turn it by hand if you need to and go through the motions so that you can get a chance to learn from it. We're going to shift to the most complex cut using the skew. That's the Coving Cut. The skew really isn't designed for this cut, but with a lot of biomechanical efficiency and understanding how to move, you can pull this one off. I'm going to shift blanks so we can show the Coving Cut. The Coving Cut is the most complex because it's a dramatic movement in your hips, twisting the tool just right to maintain bevel contact without scoring the wood with the bevel heel. Not the cutting edge, but the bevel edge that's trailing behind the cutting edge. As I initiate this cut, my wide stance, knees are bent, tool is tied into my core using my hip and a compact grip. I'm going to initiate the bevel contact first with the short point leading the cut. I'm going to rock my hips to the left and the tool tip or cutting edge to the right as I go down through the cove. In addition to the hip action and the opposite action of the tool edge, my hand that has control of steering that bevel and steering the edge is going to do a scooping motion, almost like a backhand with a slice. I'm going to engage the bevel, short point leading the cut, go through the cut, and scoop out. Initiate the cut with a bevel gliding, short point steering the cut, glide and scoop out as you come to the bottom of the cove. Now, there's one more thing that makes this an extremely complex movement. That has to do with what portion of the edge you're using to do the cut. If I were to rotate by hand and do this cut one-handed, just to show you where the shaving placement is, it starts low on the tool. As I scoop towards the middle, it comes to the middle of the edge, and as I go to finish, it comes up high on the edge. I've shown you the basic biomechanics for all 6 cuts that I demonstrated with the skew, going from simplest to more complex. Remember the planing cut, just a weight transfer left to right. A peeling cut, which is really that swan dive action of extending your knees. A paring cut across the fibers, which is very similar to a peeling cut in your biomechanics, but the edge is presented differently. A Vee cut, which is very similar to the paring cut, except now you introduce an angle to the handle, one side and the other of the V. A rolling or beading cut, which steps up in complexity because now you have this rolling or twisting of the handle as you move your body from left to right or right to left. And the last cut that I just demonstrated, a Coving Cut, the most complex of them all, because it's an awkward little scissor motion and scooping with your hand at the same time. Have fun practicing all 6 of these cuts. My hope is that the biomechanics that I've introduced to you will give you a different understanding of how to control the tool. It's not just about where the tool meets the wood. It's about how your entire body moves to control that tool and to control the edge and to create nice, smooth, flowing curves or to create crisp details. But it's all about predictability and building your confidence at the lathe.